My name is Walter Barakoff. I'm Chairman and Chief Executive Officer of Lion One Metals.
I'm Dr. Quentin Henney. I'm Technical Advisor to Lion One.
My name's Stephen Mann. I'm the Managing Director of Lion One Metals.
If I didn't live in Canada, I'd certainly be living in Fiji. The setting is beautiful.
It is a tropical paradise.
The people are friendly.
And in Fiji, there is a lot of gold.
So how big is this system? Bigger than I ever dreamed. Incredible.
Originally, I met Wally Burkhoff back in 2004, 2005. Then in 2011, he asked if I'd come and have a look at Tuvatu, just to give my opinion. I'm a geologist by profession. So I went there, had a look at the project, thought it was fantastic. In 2013, we completed the Environmental Impact Assessment, the EIA. We completed a significant drilling program in 2012-2013 of around 15,000 metres. We updated the resource in 2014. We completed a preliminary economic assessment of the project in 2015. We completed Operation Environmental Management Plan, Construction Environmental Management Plan, the Rehabilitation Closure Plan, and also we applied for the surface lease, equivalent to a native title lease, and ultimately the mining lease. And it all culminated in the mining lease being granted in 2016.
But everything changed with Quentin coming aboard. That was the turning point, a big game changer.
It was the introduction of Quentin at the beginning of 2019 that really gave us a better insight and the realization of the significance of the alkaline systems.
There's a handful of alkaline systems around the world. They're not the most prolific type of gold deposit, but they tend to be very well endowed and have gold inventories on the order of tens of millions of ounces. They're very highly sought after by major mining companies. Virtually every major mining company has an alkaline gold system in its portfolio. You look at Newmont, they have the Cripple Creek deposit here in Colorado. You look at Barrick, they've got a joint venture at Porgera in New Guinea. I've gotten to know Wally over the past couple of years. I was talking to him about the system there at Tuvatu for a few months before I actually visited the site. But I got to visit in January of last year. I walked up to the drill core. They had several holes laid out for me to review. And the first thing that jumps out at me is this mineral called roscalite, typical of alkaline gold systems.
When Quentin started to point out the tracer minerals, specifically roscalite, which I'd never seen before or identified, it all started to come together. When he started picking up core with roscalite in it, it was the obvious marker for an alkaline deposit. I'm still very excited. It's incredible. It's just getting better every day.
Alkaline gold systems are basically gold systems that are related to magmas that have emerged up from the ground, deep in the ground. And these magmas have a lot of alkaline metals. This is the Romani vein from Porgera. This vein is only about 3 or 4 centimeters across. You can see abundant visible gold on the margin of the vein right here. This greenish colored material here is a mineral we call roscalite. That's the environment you need to create high grades in an alkaline gold system. All right, let's go over here to the right-hand side now. This is Tuvatu. Along this margin right here, all these little pinpoints of bright yellow are visible gold. And then right here along the wall, that darkish green stuff along this margin, that's roscalite. So what am I saying here? I'm saying that the vein here at Tuvatu is showing us the same pattern, the same depositional process that formed the vein at Porgera. This vein at Porgera accounted for much, if not most, of the gold production at Porgera. They are absolutely full of gold. That's what gets you really excited. As a geologist, that's the kind of the holy grail of an alkaline gold system.
In the middle of 2019, we ended up getting the rest of the caldera, the other 2/3 of the caldera, which we originally applied for back in 2013 and then 2014. We wanted the whole caldera because the whole caldera was the important part of making the big picture. And that's what really created the momentum, the impetus for us to move forward, because the first time in the history of the project that one company had held the whole caldera and we could actually carry out systematic exploration within the whole area. The direction of the company over the next year or so is going to be twofold. Firstly, we want to accelerate our deep diamond drilling for proof of concept. We already know the mineralisation extends down to 300, 400, 500 metres and is still just as good at that depth as what it is near the surface. Typically, alkaline deposits extend down to 1,000, 1,500 metres. We have a spectacular amount of geochemical anomalies that are waiting to be tested. So, secondly, in the drilling, will be to target some of those anomalies.
Let me describe what CSANT is first of all. It's an electrical technique. So you basically put in electromagnetic waves into the ground. This technique actually allows us to see down into the ground upwards of about 1.2 kilometers. What you're seeing here is more or less an east-west section through the Tuvatu lodes. The Tuvatu lodes are these guys right here. These are the block models for the lode system. They've been drilled from surface down to about 350 meters of depth. The whole image from top to bottom is a little over a kilometer. This is our lode network. It's like branches of a tree. You can see how all of these branches are converging, and they ultimately look like they converge on this resistive structural feature that extends down into the ground. That now is our target. That's where we think we can find, a high-grade root feeder structure. Right there, you can see another double or potentially triple to the system with depth.
At the moment, we send all our samples to Australia, and it can take anywhere from 1 month to 3 months to get the results back. We needed a laboratory that we could use ourselves, and we could have very, very quick turnaround. Ultimately, when we mine, we have to have results back within 12 to 16 hours.
The million-ounce resource that we're looking at, there is an existing PEA on it, and it proposes a production scenario. So our plan is to go ahead and prove that out by using a pilot plant. The original PEA was based nominally on 600 tons a day.
But we thought, why don't we start at a 250 to 300 tonne a day process plant? That way it'll be very low capital, negligible dilution for shareholders, no debt, and we can actually de-risk the project even further by mining and processing and understanding the ore body even better.
Tuvatu is fully permitted and shovel ready.
People from these major mining companies come and see. Those who know alkaline systems really well can readily see that Tuvatu is a big system, and they know right away, yep, this is the real deal.